Welcome to our lesson 3 on vectors form 2. Okay, vectors form 2. I've done 2 lessons already, so this is the third lesson. This third lesson is going to focus on vector addition. How are they added? In life, application in life, if I'm moving from one point to a destination somewhere, sometimes it calls for connection of vehicles or planes or trains. Okay? Sometimes we say stopover. You don't get direct vehicles. So you see, the essence is your aim is to move directly to some point, to a destination. But the transport system sometimes will not favor you. Therefore, you move from where you are, you go to some point, and then connect. So the key thing we are doing is connection. In life situation, it is called connection. Connect so that you proceed with the journey. Okay? So if I'm moving from here to Thika, okay, I take a matatu from Kikuyu, I go to Nairobi, then connect to Thika. Basically, that is what we call vector addition. Okay? Vector addition. From one point to another, then from there, find your way maybe to your destination or yet another point, and then connect until you reach your destination. Those pieces of movement that take you to a destination in maths, vector addition. It's simple as that. So 2 or more vectors can be added when they join together. They join together. That process of joining sets you off on another piece of movement. That is the essence of vector addition. So the connection where it ends, it facilitates the other movement, but with view to reaching your destination. So another vector starts. So these are movements. Our movements from one point to another in physics are called displacements. If I tell you, take this, you bring it here. Okay, can you see? Can I say, take this, bring it here? Look, a movement, you don't do. It doesn't work like that, folks. If it is from here to this point, you just displacement from A to B. Direction was defined. You don't go on meandering at it, you are doing your things and then you place. No, we don't do that. This is what we are doing. Life situation simplifies your understanding of vectors. Now what we are doing is connection, but in the right language, mathematically, vector addition. So look at, we concentrate on the top because I can see I have some space to write, and here. Look at vector A and look at vector B. Okay? So vector A is this and vector B is that. this is the direction of B, this is the direction of A. So in a sense, what I'm saying, if I start from here, I can come here, and I can see there is a connection of my movement. It's just like current again. If you're doing physics, flow of current, So I move from here to there. Where it ends, where this vector A ends, you connect, you move, you take another matatu. Okay? So we can say this is my starting point, this is my end point, if I may use that. This is where I started, I joined, and I ended. So essentially, I am talking of Sj plus Je. If I move from S to J, so if I move from S to J and connect, okay, connect. So what am I doing now? I'm connecting a journey which will take me from J to E. Look at that. That movement is as good as saying S to E. Very simple. Very simple. Enjoy that? Start. I went to town J. Town J, I got a matatu to take me to town E. So what was your aim? To move from South C to some point E. Embakasi. Haha. South C, Embakasi. Good example. Where are you going? I'm going to Embakasi. Where am I now? I'm at South C. An example. I'm here. Somebody asking me, where are you going? I'm going to town E. Then this is the description of your movement. But those movements are what we call vectors. So there is vector Sj and there is vector Je, capital letters. Another way of expressing vectors, use of small letters. So look, A join B. There is flow. So essentially, this is what we are talking. Come here. Here, I focus before I go up. Get you another example. Focus. So, we wrap this first for explanation purposes. I have OD. I have this movement, OD. You can see there. It's a vector. There is yet another vector. Key thing we are learning, this, where it ends, it has to join another one. You can see the arrows don't contradict. They don't move opposite. So you can see this after you have reached. The arrow tells you, come this way. Come this way. So you go. So what have we done here? Check again. Can you see here? Yes. OD. There's a movement. There's a vector. When I moved from O to D, I connected another matatu, which now takes me from D to A. Those are movements. Those are two vectors. Those vectors, one ends, another one starts off. If you started your journey at O, definitely when you are asked where are you going, you would have said, I'm going to A. This one is OA. That movement from O to A was made up of two movements, OD plus DA, and you get that. Okay? So this is what we call vector addition. Where your movement ends, you move to another matatu to take you to your destination, life situation there. I want you to notice as we move on where you are going in short form. Description of your movements, the intention, right? That is what we do. Now, if I am asked, what is magnitude of your movement? This being triangle, this being a triangle, this is my movement. That has been my movement from O to A by addition of vector OD and DA. This is now a right angle triangle. There are 4 units here, and here there are 3 units. 1, 2, 3, 4, and then 1, 2, 3. So how do you get this? 4 squared, 16. 3 squared, 9. You get 25. Square root of 25. So we have 5 units. So if I'm asked, what is OA? It is written like that mathematically. Modulus. Okay? Modulus. Just a bit. Modulus. So the movement I've done, OD plus DA is equal to OA. That is vector addition. But if I'm asked, what is the size of vector OA? The length. Remember, size, you use 2 methods. You measure length or use Pythagoras. So I've used Pythagoras. How is it written mathematically? That. How is it read? Modulus. Size of OA. Size of OA. So symbolically, we put some 2 lines at the beginning and at the end. Right? So we go back as I conclude here. As I conclude, look at this. This is vector L, this is vector D. Vector L and vector D. If I say use vector L, where I have reached, I should connect vector D. So the way they are drawn, you can do adjustment. How? You do this vector, you bring it here. We learned parallel, not parallel, equivalent. So this vector should not be drawn here. That would be a trick. But since you have done equivalent, now I bring it to this lesson. This is a diagonal of 1 square. So even this can be written as D. Okay? Now for today purposes, addition. So how will it be? Let us say this is the start point. This is the connection. This is where I end. Now I can add. I've used which knowledge? Equivalent vectors. The 2 vectors drawn originally are L and D. From this level, I cannot add them. Please understand, from this level, I cannot. Why? The basics of addition is where one vector ends, the other one picks up. So this one, this point is the beginning of both L and D. In as far as that is concerned, they cannot be added. my basic of addition is where one vector ends, the other one joins. So what next? I use the knowledge of equivalent vectors, that this vector D can be drawn here. Now, with my explanation, where L ends, I've connected with D. You can see the arrows now match, so that I have a starting point and end point. Okay? You get this right? I've made use of equivalent. So this has gone there. Now I have SC. See, I have, can I write here? Yes. SC. Now I have SC. When I have reached town C, I am town S, starting point. I've gone to town C to connect. So I'll move from S to town C. Then connect. Add. Vector language, add. Layman's language, life situation, I'm connecting. Now I move from C to my destination. Look, the beginning where you are is S. Where you have ended, E. Then when you start writing and conceptualize, internalize the mathematics and life situation, you are very far ahead. Okay? Look at the beginning and at the end. So there is no contradiction. It is a backup in life. I started here, went to town C. At town C, I connected another matatu from there to my destination. But when you are at home, town S, if you are asked, where are you going? You will say, I'm going to town E. You don't give. And if you give description, as far as your communication system are concerned, this will be correct. So folks, that is what we do. Next lesson, we shall do still vector addition, but borrow some movement with respect to Cartesian plane. Because you see, I have introduced Cartesian plane. So we should be able to borrow those movements. That when we talk of a point, in it, it has a movement. We shall connect those so that you are comfortable right from beginning. Remember, this is Form 2, from scratch. So you will have these lessons maybe up to lesson 7 or 8. What you need to do is you take your book, take your Cartesian plane, try to draw vectors that can connect, and then give them letters. See if you follow all this. If I am doing addition, the very first letter and the very last letter in my addition will form the question that you can be asked in life situation. Where are you going? It will always be the first letter and the last letter. Even if you have 3 connection or 4, it doesn't matter. Even if you have 3 or 4 additions, the very first letter and the last letter will be a simple vector from your place to destination. Keep on prescribing, you will enjoy it. Any problem, you put it as a comment on YouTube, but don't be broad. If there is a topic in Form 2, you say moments Form 2. Don't tell me Form 2 work. No. Be specific, because here we are specific and to the point. Till then, subscribe, put your comment, put the subject, either maths or physics, put it specifically and the form. I will always accommodate it in the program. Bye bye.